Hello and welcome to my channel. I am Mensa Augustine. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and you want to subscribe, please kindly subscribe for us to grow the mathematics community. In this lesson, we'll be looking at the behavior of a rational function. That's the end behavior of a given function. So let's take this one. But before we go, thanks to Ebenezer and Helen, Harriet, I think Peace Adenya, and James. They requested for this video. They are all schooling at the University of Lebanon, Ghana. So now let's go through this lesson. Let's take f of x equal to, let's take 4x squared divided by x squared minus 1. And then let us discuss the end behavior of this rational function. Now, you see that once we have this, we have to determine the asymptotes. That's the first thing. You have watched the first lesson that I did on polynomials. We are not having any denominator and whatsoever. So it is continuous everywhere. But this one, since it is a rational function, we need to find its asymptotes. So how do we find the vertical asymptote? By equating the denominator to 0. So we take x squared minus 1 equal to 0. And that gives us x squared equal to 1. We have x equal to plus or minus 1. That is, if we take square root of this, we get plus or minus 1. Wow. And this is the vertical asymptote. That's how we spell the asymptote. I'm a mathematician. Okay, so now let us discuss the behavior of the function around the asymptote. So here we will look at as x approaches plus or minus 1, that is for the vertical asymptote, and as x approaches plus or minus infinity, that will give us the horizontal asymptote. So these values will give us the behavior of the graph or the behavior of the function. Now let's see. Let's take the limit as x approaches positive 1 from the right of 4x squared divided by x squared minus 1. This is the same as writing the limit of 4x squared as x approaches positive 1 from the right times the limit as x approaches positive 1 from the right of 1 divided by x squared minus 1. That is, we are using the product rule. So this will give us 4 times the limit of x squared as x approaches positive 1 from the right times the limit of 1 divided by x squared minus 1 as x approaches positive 1 from the right. And this one will give us 4 times 1 squared times the limit 1 on x squared minus 1 as x approaches 1 from the right. And this will give us 4 times the limit of 1 on x squared minus 1. And now, as x approaches 1 from the right. Now, since we are looking for x approaching 1 from the right, I'll put 1 here. And on the right side of 1, we are coming closer to 1. So if we are coming closer to that 1, then we can use 1.00001. This is very, very close to 1. You can use 1.00001 to test. So here, this is the same as 4 times 1 divided by 1.00001 squared minus 1. Check that with your calculator and you see what you are going to get. You have 4 times 1 divided by 1.12341 squared minus 1. Oh, we are having 1.9991235. Sorry, 19999. That is 123. That's 199,999, which is a very large positive number. So if you take 1.00001, it means that this number will even increase. So it implies that the limit of 4x squared divided by x squared minus 1 as x approaches positive 1, this limit will increase without bound. That is, it will approach positive infinity. So here, this one was just to bring the understanding to tell you that this one will approach positive infinity. So I've done this calculation for the rest. So the rest, I'm just going to put substitution, then we move fast, right? Okay. So we have that. Let's put this one there. This is the behavior, the limit as x approaches positive 1 from the right. 4x squared divided by x squared minus 1 will go to positive infinity. You have 1, 2. Then check the limit as x approaches positive 1 from the left. 4x squared divided by x squared minus 1. This one will also be the same as 4 times the limit as x approaches positive 1 from the left, 1 divided by x squared minus 1. So on the left of 1, what can we use to check? So if you want to do this, you go through this whole process. I've done it once, I'll not do it again. Yes. This is not negative 1. This is to show that from the left. So this is positive 1. This is positive 1. 1.00001 is on the right. And on the left, you can have 0.9999. Yes. This on the left, 0.9999. So let's check that one and see. If we take 1 divided by 0.9999 squared minus 1, we can take value very, very close to 1 than what I've taken, like 0.99999 and check. So if we take 1 divided by 0.1234 squared minus 1, wow, we are getting minus 5,000 point something, which means it will decrease without bound. So it will approach negative infinity. Very simple as that. So we've tested it. So now we have this one equal to negative infinity. Wow. Now, we are having plus or minus 1. We finish with plus 1. So we take the limit as x approaches negative 1 from the right of 4x squared divided by x squared minus 1. Then look at the limit as x approaches negative 1 from the left. Okay, let's see what we get. Now, this is negative 1. So, on the right, we are coming closer to 1. So you have 1.00001. Here, we are coming closer to -1 from the left, so you can get -0.9999. And I've used this already. So here, if I take 1 on 1 point, okay, on the right, you are going to have negative. Negative 1.00001. Yes, that's what we are going to have. Or no, I've interchanged the position. Yes, because here on the left we are moving to -2, so you have -1.00001, and here we are moving closer to 0, or 0 is moving closer to -1, so you have -0.9999. I hope it's okay now. Here 1 is moving to -2, and here, sorry, -2 is coming to -1, and here 0 is coming to -1. So what you've chosen is very nice. So on the right side, we use -0.1234 squared minus 1. So let's take that one. 1 divided by -0.1234 squared minus 1. Wow. And this one will go to 1, 2, 3. And that is positive infinity. So it will go to positive infinity. That is on the right of -1. This one will go to positive infinity. And let's check for the left. Oh, hey, I mistakenly put negative here. 1 on bracket -0.1234 minus 1. In fact, this will go to negative infinity. I mistakenly point 1 here, so it will go to negative infinity. And this one will by always go to positive infinity. So let's take that one. Minus 1.12341. Correct. This one is going to 175. So this will go to positive infinity. Wow. So this is the behavior of the graph. Those people who were requesting for this video. So here we have 1, 2, 3, 4. Have you finished? No. We have to take the limit of f of x as x approaches plus or minus infinity. Right? Correct. So here we take the limit of 4x squared divided by x squared minus 1 as x approaches positive infinity, and this will give us 4x squared divided by x squared, or divided by x squared divided by x squared minus 1 divided by x squared, and this will give us 4 divided by 1 minus 1 on x squared, and that is 4 divided by 1 minus 1 on infinity squared, that is 4 on 1 minus 0, that is 4. Wow. So 4 is a horizontal asymptote. 4 is a horizontal asymptote. In the same vein, if we take the limit as x approaches negative infinity of 4x squared divided by x squared minus 1 equal to, we having 4x squared divided by x squared, all divided by x squared divided by x squared minus 1 divided by x squared. That will give us 4 on 1 minus 1 on x squared equal to 4 on 1 minus 1 on negative infinity squared. That will give us 4 on 1 minus 0, that is 4. So here, once you've gotten the plus to be 4, we will get this one also to be 4. And this is what we call the horizontal asymptote. So this is the behavior of the function. This is the behavior of the graph. This is the behavior of the function. So if you are told to find the behavior of the function, this is the process that you have to go through. Very, very simple as that. But in case you are told to find the asymptotes first, and you find the horizontal asymptotes, there's no need going through the horizontal asymptote again. You can just leave your answer at these 4 points. Thank you for watching. If you have any question, leave it at the comment section. Please, I need your comments. I need your comments. I need your subscriptions. I need your likes. If you have any question, just send it to my WhatsApp number +233 245 360 793. It is also my mobile money account number. So if you want to support my channel, you can donate into my account number. I'm Mensa Augustine. Bye bye.